After the Fukushima accident, many people were left to wonder how safe nuclear power really is and how nuclear power works today. Hi, I'm Kyle Duyne, and today I'm going to explain to you a little bit of how nuclear power works and go into a little bit of detail on how safe nuclear power is today in the United States. So let's get started. I have a couple posters here, and I'm going to explain to you the difference between a pressurized water reactor and a boiling water reactor. So I'm going to first explain to you how nuclear power works on a pressurized water reactor, and then explain the differences between a pressurized water reactor and a boiling water reactor. So what happens is, in the reactor, there's little uranium-235 pellets, and the neutrons split the atoms from the uranium-235 pellets, which give off heat. And this will heat the water in the reactor, which will go through the primary line in here. And what the pressurizer does, which is right here, it keeps pressure on the liquid water, because the liquid water is so hot that it could boil. So putting pressure on it keeps it in the liquid form. And it'll go into the steam generator, and the hot water will go through U-tubes in the steam generator, and there's water on the outside of those U-tubes in the steam generator. And that hot water that goes through the U-tubes will heat the water on the outside of the U-tubes of the steam generator, converting it into steam. And that steam will go through here, and it'll hit the turbines. There's high pressure turbines and low pressure turbines, and what that does is the steam will turn the blades on those turbines, which will which will make electricity. And that steam goes through a main condenser after it turns the blades on the turbines, and it gets converted back down into the liquid form. And it'll go right back in here on the outside of the tubes of the steam generator. So what that does, it'll just keep going in a circle. It'll keep converting into steam and then condensing back down to liquid. Converting into steam, condensing back down into liquid. And this water over here in the reactor, it'll stay in this primary loop, and it'll keep going through the reactor, through the steam generator U-tubes, and back. Now the difference between a pressurized water and a boiling water reactor is, on a boiling water reactor, there is no steam generator and there is no pressurizer. Everything, it gets converted from the fission process heats the water, and it heats the water in the reactor, and it just converts it right in the reactor into steam and goes right down into the turbines. And that's how that creates electricity. Now, the other difference between a boiling water and a pressurized water reactor is that when a reactor is shut down, you have to stop the fission process. So there's control rods in here that stop the fission process. And in a boiling water reactor, these control rods are pushed up from the bottom in order to shut the reactor down. And in a pressurized water reactor, these control rods are pushed in from the top in order to shut down the reactor. Also, when the reactor is shut down, you're going to need something to cool the reactor off while it's shut down. And that's what the residual heat removal system is for. And in a pressurized water reactor, this system has its own separate building. It's called the auxiliary building. And then in a boiling water reactor, that system, the residual heat removal system, is directly in the containment drywall building. So it doesn't have its own separate building. Now I'm going to explain to you a little bit about how safe nuclear power is, and I'm going to use an example of the residual heat removal system, how there's two different trains on the residual heat removal system. So if one of those trains goes out, one of those trains can still cool down the reactor by itself, but when the reactor is normally running, both of those trains are used to cool off the reactor when it's shut down. I also have another visual aid here, and this is a mock U-235 pellet. It's basically the same size, same shape as the uranium-235 pellet in the reactor. And what this basically is telling you is that one of these little uranium-235 pellets is equivalent to 149 gallons of oil, 1 ton of coal, and 17,000 cubic feet of natural gas. And basically what that's saying is it puts out the same amount of energy as that. So it's very environmentally friendly. Other than a couple of accidents that we've had, nuclear power is actually one of the safest industries in the United States today. So today I've talked to you about the difference between a pressurized water reactor and a boiling water reactor. I've also talked to you about how nuclear power works and how safe nuclear power is in the United States. And I hope that I have educated you a little bit on nuclear power and converted you from an anti-nuke to a pro-nuke.
Very good.